In the following presentation, we're going to have a look at what's new in Alphacam 2014 Release 1. A brief summary of what we've just seen. We've seen the ability to define solid tools in Alphacam for mill, router, stone and lathe, as well as turrets for lathe. Multi-processing of 3D machining operations. The ability to read Spaceclaim solids directly into Alphacam. Cut Spline Polyline has been improved, so we can do multiple cuts and support bidirectional. And we've also looked at improvements to CAD-to-CAM, where we can now process solids. In the following presentation, we're going to look at the definition of solid tools for mill, router and stone. Multi-processing of 3D machining operations, utilizing multi-core hardware processing, and the ability to input Spaceclaim models into Alphacam. So we're going to go to the File menu, and we're going to go to Input CAD, and on the file type list we can see we've got a new input, which is Spaceclaim. We can say OK to that. Here I have a Spaceclaim file, which is scdoc, Spaceclaim doc. If I right click on this and open, I've loaded a free viewer onto my laptop, and you can see here the tool, the file that's come in, the solid model. So if we open, and as we see as the Spaceclaim file comes in, we've got the same, and obviously it's maintained the colours as well as they've come into the part. A couple of bits of information that I want to have a look at this solid later on for the tool definition is the tool length, and also the point at which the holder goes into the spindle nose, as we know it as the gauge length. So I'm going to go to Utilities, Report Coordinates of the arc centre of here. And I can see down at the prompt bar that's approximately 93, which is fine. Okay, we'll do that again. Report coordinates of the arc centre of here, and that point's going to go into spindle nose, and I can see that's about 116. So if we go to the File menu now, the Machine menu, and we go down to Define Tool, a flat end tool. So we've got a tool number and an offset number. Let's make those the same. So the tool length is a value that we reported, which was 93, and we've got a diameter of 16. Let's just put some fixed speeds and feeds in here. Maybe a spindle speed of 5,000, and we'll put in a feed rate and a down feed. So what we now have is a new button in here, a simulation. And we're going to use advanced tool graphics, and the tooltip to gauge length is now in this dialog box, and this is 116. Okay. Pick reference point, well that's going to be 000, which is fine. Pick all the solids in this case. And now what do we want to save the tool away as? So if I now go to the Machine menu and I select a tool, and we can see that we've got the solid tool there. So let's use this tool now to do some machining of a solid. So we're just going to go to the File menu and open, and in here we have a simple 3D solid. What I now want to do is get a material around the outside, so I'm going to do a rectangle from the endpoint, and we're going to snap on the corner of the solid, which is going to project the geometry up into flatland, the current work plane. We're going to use the offset command, offset by a distance of 8, a complete geometry around the outside. Now what I want to do is find out from the model the depth of this material. So we're just going to go to Solid Model Utilities, Face Edge Point Details. If I navigate around the solid, it gives me the information. So if I pick on the corner, I can see that my depth's -25. So if I go back to the 3D menu, set materials, pick the square, and we're going to go down to -25. I'm going to go ahead and select that tool, that solid tool that I previously defined. And we're going to go to the Machine menu, and we're going to do some 3D solid machining, Z contour roughing. So I'm going to do some contour machining, and we're going to be optimized. So OK to that. Safe rapid level, rapid down to, and now we've got a maximum depth of cut of 4mm, and what we're interested in here also is the intermediate slices, so we've got that set to 1. Okay, tool number, speeds and feeds obviously from the tool definition, and we've got 0.25 stock in X and Y and Z. So if we say machining and then finish, it's created the tool path for me. So if I right click now and do a solid simulation and play, so now we can see our nice solid tool. The C solid tools are currently only supported in solid simulation and not in center simulator, and those are the intermediate slices that we talked about. So it's taken 4mm cuts initially, and then it's going back round to take the 1mm off, a little bit like rest machining. So if we come out of here now, we're going to undertake some more machining. For good housekeeping, let's just hide our first tool path, go to the machine menu, select another tool, which is our 8 ball, and we're going to go to the machine menu, again 3D solid machining, some finish machining, and we're going to do parallel to a boundary. Select the boundary. Tool number, speeds and feeds, so we're happy with all of that. Width of cut is 2, and we're machining optimized. So we're familiar with this. So let's say the solid and then finish, and it creates the tool path for me. I can right click on the operation and edit it. The associativity and editability is greatly improved within Alphacam, so I'm going to put a step over at 0.25. Say OK to that, and it's created the tool path for me. Okay, again about the editability and associativity, I'm going to put a fillet radius of 50 on the top right hand corner. I've got an asterisk to say that my associativity has changed, so I'm just going to use the update command, and here it's going to update the tool path for me. So if we show the initial operation, the Z contour roughing, we're just going to right click on this and we're going to edit it and just change it to a very fine step over, some depth of cut. So we're going to change the depth of cut to 0.5 and the intermediate slices to 0.25. So when we say OK to this, we can see we've got processing. The tool path is being processed. So what it's using is multi-core technology. This means that I have the ability to go on and continue using Alphacam to do another operation, in this case a feature extraction, rather than having to wait for that tool path to finish. Let's just finish off this part now, and we've got a machining style. And we can run this to all and finish. So as I said, the last thing that we were looking at there was the processing, which allows us to use multi-core technology on our hardware. While it was processing, we can also right click on the command and abort it, so to change the settings. In the following presentation, we're going to look at defining solid tools and turrets in Lathe. So we're in the Lathe module. We're going to go to the File menu and Open, and then here we have a file called External Rougher. This file is made up of various solids and a 2D geometry that represents the tip of the tool. We're going to go to the Machine menu, we're going to define a tool, and we're going to go 2-axis tool, 1 programming point. So pick the 2D geometry and pick the tooltip arc. So here we're familiar with this tool number, clearance angle of 5 degrees, and we're going to use advanced graphics. Edge tip relationship. Now what it's asking me for is a turret location point. This corresponds to a point on the turret itself, which we'll see later on. It's now asking me to select geometries for the tool graphics, which are the solids here, so apart from the 2D geometry. And then finish, gives me a preview of the tool, and now asks me to save it away, and I'm saving it as external rougher. So if we go to the File menu now, and we go to New, I'm now going to go to a new pane in the Project Manager, which is Turrets. I'm going to load a turret. Turrets can be from solids or extruded or revolved 2D geometry, and here we have a turret. If I move down the turret locations, they're highlighted, and if I look at my empty one, I can see that turret position that corresponds to the one on the tool. So I'm going to right click, load a tool, my external rougher. These are familiar with these settings, and it puts the tool in position ready to go. We're now going to set the turret home position, so we're going to right click. So we're going to put an X value of 600 and a Z value of 400. And while we're here, we're also going to set our tool change position. So set tool change position, X is going to be 200, Z is going to be 100. So now what we're going to do is read in a solid model. So we're going to go to Input CAD, Parasolid, bring my simple solid in, which has got some 2D machining on it, and it's got some periphery holes. Let's just refresh. So we're now going to go to the 3D menu, Solid Model Extract, and we're going to do a spun outline. So it creates the geometry and also puts it on the work plane for me. I've got my 2D geometry to machine, but what I need now is my billet. So I'm going to create a line from X0, Z1, 1 mil on the front face. Now it's asking me my diameter value. I brought this from a model, so I'm not sure what it is. So I'm going to use a tip, which is the same endpoint of here for my X, and I'm going to add some stock. And my Z is the same as the last Z. And now I'm going to do the same for the Z, so it's the same as the endpoint of there. It's okay to that. I don't want this to be a bar, I want it to be a slightly different billet shape, so I'm going to use the chamfer command by 10 to 20. Okay, so if we go to the ISO view now, cancel my work plane. And what I want to do is just feature extract one of the holes. So we're going to go to 3D, Solid Model Extract, Drillable Hole Extraction. Set that. And it finds that 2D geometry for me, which we're going to machine later on. I'm now going to select a tool, but rather than go from the machine menu, I'm going to select it from the turret. So I'm just going to right click, select a tool, and it indexes my external rougher into position. I'm going to go to the machine menu now, and I'm going to do some conventional turning, some facing. Select the billet, select the part, 0 stock, width of cut, tool number, speeds and feeds. And how do I want to get from tool change position to start of cut? I'm going to use the same tool now to do my roughing on the OD. So conventional turning again, roughing on the diameter, select the billet, pick start point on part. Well, I've already faced it to size, so I'm going to start at the beginning of the radius and go to the end of the part. Pick point on tool side of geometry, is it OD or ID? Let's just put some stocks in here. Depth of cut, tool number, speeds and feeds, and I'm going to use linear because CAN cycle only does a bar for me. Now it's saying how do I want to move from the end of my facing operation to the start of my roughing operation, and I'm going to come out in Z so I'm well away from the part, and it puts a rapid move of 10 mil off the front face. I'm now going to select another tool, so I'm going to go back to my turret and right click my external finisher and select. It now wants to know my previous tool, how I want to get back to the tool change position. I'm going to go direct. I'm now going to go to the machine menu, again conventional turning, and I'm going to do some finishing. Pick start point, again the start of the radius, and then the end point. Keep going. Tool number, speeds and feeds, default lead in, lead outs. How do I want to get from tool change position to start of cut? Now, because I've selected the tool from the turret rather than from machine select tool, the operations are the same color, but I know how to change this. I can just edit tool color. Let's change it to red so we can see a difference there. What I now want to do is to select the tool to drill the holes. If I go to my turret, I can just look at the different locations, and it highlights the tools in the turret. So I've got periphery drills and axial drills here, so I need to select the one. So I highlight it, select the tool, go to tool change position for the last tool. How do I want to get there? Okay, let's go to the ISO view. So now what I want to do is I want to drill this hole. So I'm going to go to the machine menu, Z-axis machining, drill tap holes Auto Z. I'm going to do some pecking. Peck distance of 2. Select the geometry and then finish. So what I now want to do is rotate this, so I'm going to cancel the work plane. I'm going to select the tool, the tool path from the project manager. So I'm going to use the rotate command, which tool path I want to, and I can see the color is the same. Linear axis of rotation, revolution, angle of 90, and how many copies including the original? 4. So that's my part machined. What I can now do is a solid simulation. And play. So we can see the tool coming in, and we can also see the turret moving, and as it changes tool we can see the tool indexing. It drills the holes on the outer diameter. In the following presentation, we're going to look at the improved Cut Spline Polyline command, which now supports multiple cuts and bidirectional cuts. In the Ultimate Router module, what we have is a part loaded, and what we have here is a solid model and also a 3D polyline which has been extracted from an edge. We're going to go to the machine menu now, select the tool, which is a 10mm flat, to the machine menu, and we're going down to Cut Spline Polyline. So depth of cut. So this is how much further we want to go past the polyline. So let's say 2mm. Safe rapid level 20. And what we have new here are number of cuts. So we're going to say 3 cuts, and also we've got a bidirectional option here. Initial stock is 20. So it's asking me to select the polyline, and we're going to go parallel to solid model faces, show the ghost tools, and we want to cut to the left, and we're also going to apply a tool lead in, lead out. So select the solid model faces, and we're going to do here a tangential run of faces, finish, and here we can see the toolpath created. So if we do a simulation and play, so obviously Cut Spline Polyline isn't a new command, but what is new is the ability to do multiple depth cuts and also to run bidirectional. So as the tool goes along, we'll see it changing direction and taking more material off. Style layer processing can now read, feature extract and machine solids ready for automatic nesting within CAD-to-CAM. First of all, I need some solid model parts that I'm going to process within style layer processing. So what I have on the screen within Alphacam is a solid model assembly of a cabinet, and I can see on the left here in the layers pane of the project manager the different parts. What I'm going to do is use the command in the file menu, which is save solid bodies to files. I'm not going to align this, and and I'm going to say all. So what it's going to do is just save away each of these individual solids as individual files to a separate file. CAD-to-CAM is a nesting engine. Style layer processing automatic machines parts prior to nesting within CAD-to-CAM. So what I'm going to do now is go into CAD-to-CAM, and first of all we're going to have a quick look at style layer processing. It's going to ask me to clear the drawing on the screen, which is fine. What I have here is something called layer mapping setups, and if I come into here, if I go to edit, this is very much like auto styles. What I have on the left here is a series of layers, and we can recognize these layer names from the feature extraction. And what I have on the right here, I have my auto styles. So I can drag different auto styles onto my different layers. If I double click on here, I can do things similar to what I do in auto styles, like set my tool directions, but I'm not going to set anything in here because I'm actually going to use the tool directions that have been generated from feature extraction. I can also say use geometry auto Z levels. Again, these will be created in the feature extraction. My setup is called UGM. I'm going to give this a job name, and I'm going to go to my part files. What I want to do is import my files, so I'm going to say add. These are the files that I saved away previously, my individual solid model parts. And if I go back now, I can have a look at my job data. As I said, I've got a job name in here, and now what I can do is process. So I'm just going to press next. What we can see going on in the background is the solid models being read in, feature extracted, and machined. All I need to do now is put a material thickness, which I'm going to put 18 mm in here, and if I say next, here we've got information about reports, and also we've got other things in here. Potentially we can set up multi-drilling, etc. So if I run this now, I'm automatically nesting those parts, machining them, nesting them, and also what it's going to do for me is create report data. So we're going into reports now, and we'll be able to see our nesting, how many sheets we've used, and other information. We've nested here into one sheet. So that was what's new in CAD-to-CAM, the ability to machine, automatically process solid model parts, and obviously use CAD-to-CAM to automatically nest them. CAD inputs have been improved. Alphacam is now able to read Autodesk AutoCAD 2014 DWG files. Also, when we read in CAD files, we are able to maintain layer visibility. So for example, if you've hidden a layer within AutoCAD and you read it into Alphacam, you have the ability to keep that hidden, or you can obviously tick it and switch it on. Also with DXF input, a lot of work's been done on that to tidy things up. For example, if we look at these dimensions on the right, pre-2014 they were always out of place, but now in 2014 R1 we can see that they're exactly in the middle. So thank you for watching this presentation of Alphacam 2014 R1.